Hey everyone, and welcome. Today, we're going to pull back the curtain on a concept that sounds super complicated, but is actually one of the coolest superpowers your code can have: polymorphism. Seriously, this is the secret sauce to making your programs smarter and way more flexible. So let's dive right in.
Just think about this for a second. What if your code wasn't just a dumb list of instructions? What if it could actually adapt to different situations? Make smart choices all by itself while it's running? Well, spoiler alert, that's exactly what polymorphism lets us do. At its heart, the idea is way simpler than the name suggests. Polymorphism literally just means many forms. In the world of coding, it means one single name or one interface can mean different things depending on the context. It's kind of like a universal remote for your TV. The power button is just one button, right? But it does a different thing depending on whether you're pointing it at your TV, your soundbar, or your Blu-ray player. It's one name with many different actions. All right, first up, let's talk about static polymorphism. The easiest way to think about this is to imagine the compiler, that's the tool that checks your code before it even runs, as a super meticulous planner. It wants everything figured out, sorted, and decided way ahead of time. It makes a plan, and it locks it in. And the perfect example of this is something called method overloading. Take a look here. We've got two methods, and they're both called brew coffee. Now, you'd think that would be confusing, but it's not. Why? Because the compiler is smart enough to look at the ingredients, the parameters you give it. The first one just needs to know what kind of coffee you want. But the second one needs the coffee type and a number for how many cups to make. The compiler sees these different recipes and knows exactly which one you mean before the program is even launched. So, the compiler's game plan is super straightforward. It sees the brew coffee call in your code, it checks the parameters you've given it, and bam! It finds the exact match and locks it in. This whole process is called static binding because that connection, that decision, is made statically before anything actually runs. It's fast and it's totally predictable. Okay, so if static polymorphism is the careful planner, then dynamic polymorphism, well, that's the runtime surprise. This is where things get really interesting. Here, it's the Java virtual machine, the JVM, the thing that's actually running your code that becomes an on-the-spot decision maker, figuring things out as it goes. Now, to get this, we have to talk about a key idea: inheritance. Let's just imagine a little family of coffee machines. We've got the parent, the basic coffee machine. It's simple, it does one thing: brews filter coffee. But then you've got its child, the premium coffee machine. Now, it inherits everything the basic one can do, but it's got an upgrade. It can also brew a fancy espresso. And this is where the mystery begins, because this family relationship sets up a really cool puzzle. We're about to look at a single line of code where things aren't exactly what they seem. This is where the real magic happens, so get ready for a little twist. Okay, look closely at this line. On the right, we're creating a brand new, shiny, premium coffee machine. But on the left, we're telling our program to treat it, to refer to it, as if it's just a basic coffee machine. So we've basically built a high-tech machine, but slapped a basic label on it. So here it is, the million-dollar question. Our code thinks it's dealing with a basic machine. So what happens when we tell it to brew coffee? Is it only going to be able to make a simple filter coffee? Or does it somehow remember that underneath that basic label, it's secretly a powerful espresso maker? What do you think? And boom, this is the runtime surprise. The JVM is not fooled by that basic label. At the very moment the code runs, it peeks under the hood, sees the actual object is a premium coffee machine, and it calls the more powerful, upgraded brew coffee method that makes espresso. This is called late binding because the final decision is made at the last possible second during runtime. Pretty cool, right?
All right, we've seen them both in action, so let's put them head to head in a little showdown. The plan versus the surprise. This is really going to make the difference between the two crystal clear.
This table sums it all up. Static, the plan, gets decided way early, at compile time. Its main trick is method overloading. Same name, different ingredients. On the other side, you have dynamic, the surprise. That's decided at runtime, and its technique is method overriding, where a child class provides its own special version of a parent's method. So what's the trade-off? Static gives you speed and predictability. Dynamic gives you incredible flexibility and makes your code easy to expand. Now, I know what some of you might be thinking: what about performance? And you're right, that on-the-spot decision-making for dynamic polymorphism does have a tiny bit of overhead. The JVM has to do a quick lookup. But honestly, with modern computers being so ridiculously fast, this difference is almost always completely insignificant. So we've covered the what and the how, but now for the most important part, the why. Why should you, as a developer, actually care about all this? What does mastering this concept really unlock for you? The real game changer here, especially with dynamic polymorphism, is that it lets you write incredibly clean and powerful code. You get that runtime flexibility we talked about, you unlock the full potential of inheritance, you write less repetitive code, and most importantly, you make your code so much easier to add to and maintain in the future. So, if you remember one thing from all this, let it be this. Using dynamic polymorphism is what elevates your code from just being a rigid set of instructions to being a truly flexible, intelligent system that's built to adapt and grow. It's a huge step toward writing better, more professional code. So there you have it, the plan versus the surprise. You've now got two incredible tools in your programming toolkit, the predictable, planned-out approach of static polymorphism and the flexible, in-the-moment surprise of dynamic polymorphism. So the question I'll leave you with is, the next time you're building something, which approach will you use? Thanks for tuning in, and I hope this helped clear things up.